We continue for part modeling with the number 2 bonnet part. It is shown in our view, and I will just take the view on the left side and I'm going to just model this one. I open a new part with standard millimetric IPT with double click. This is the easiest cylindrical part. We will just follow this profile. We are going to create this profile like this. I will use this profile, and also I'm going to make a revolution axis around this point. Let's start with the part. I will just save my part, which is this, the part 2, part 2, the name is the bonnet part, into, just save it. First I have opened the origin part, get the center point, make it visible with right click and left click after, XY plane, start a new sketch. Also I will switch my view to the other paint. Oh, yes, this one. I'll just start to create the profile. At first I'm going to just draw a line, and with escape also I will just create this as a center line because I have dimension values here and I would like to use that dimension values with this center line. I choose this point as my origin point and I would just like to create the outline here, which I have seen. I'm just going to make this outline. For this I just create a new line, escape, and convert it to construction in order to keep these two lines, 2 points, in a relationship. For this, I start the line first, then go up, go right side, top, with a slope again. Also, this left side, top, again, this. I'll just create the profile without magneting my sketch. This, yes, I think it is. Yeah, I will delete this one. Again, I'll just select a new line and make the trims, and I will just connect these two items, trim, and also I will just make coincident this line on this point. Okay, let's give the first dimensions. First, the biggest dimension, which is 53 and 39. First, the height from bottom side, which is 53. The biggest dimension outer, this is 39. I would like to just stretch this to keep my dimensions. Okay, after this I will just clean to see the dimensions. After this, we have a threaded fastener, which is metric 13 here. I'm going to make this major diameter, which is 32. The next one. Inside, we have 22. First, the diameter dimension relationships, 22. Then we have metric 12 at this point. Again, dimension, this one to this one, which is 12. Also, I can just give this height. It is the right time to make this one 11. Just define. And also, the outside, we have this relationship, which I'm going to continue. Top side, we have 28, which is this one. I'll define this dimension 28. Again, I will define 13, which is inside of this one, and also this figure. Also, I have 18 millimeter. 1 by 1. The first one, it is the 18. Just keep this dimension inside, and this is 13. I'll just undo here. I will just go over these dimensions. The first one, it is 10. This one is 10 millimeter. This line we have 4, then after 3. The first one, it is 4, then after 3. This slope, this line, it is 12. Also, I have another step. This one. We have a point here, which is this one. And I will just go inside and define this length. It is also 12. As you see, we have a chamfer inside, and we have a 3 millimeter. It is not seen very clear. For this reason, I will just leave as it's empty, but I know we have a gland part which just fits inside. We will just correct that size after we have the gland part, which is this one. Okay, let's continue. It is not very clear. We have 12. Also, this we have 12, metric 12. So we have a little diameter, which is 7 millimeter, and it's not very clear. And I will just look for this one in the assembly. Drawing information. I'll just switch to this one. As you see, we have some things at these points, and it is not very clear. Anyway, we will continue. Okay, I'll just switch this one and switch to the inventor side. Let's have the finished sketch because we have already done the most things. Have the revolve tool. We have one axis and one profile. It automatically grabs and make the revolve side. Okay. We have a threaded fastener on the outside, which is 12 millimeter. Let's have the thread command here with metric 18 I will just change the ISO metric. We have the thread size 18, and the depth, I'm going to just define this depth with 12 mm, which is on the outside. Okay. Also, we have on the bottom side, we have metric 13 and metric 12, these 2 points. I will also define those dimensions. From the first one, metric 13, again ISO, and I will just get the whole way here, which is 10. For this reason, I'm going to make this with 10 mm with full depth. And after that, to see better, I will just make a half sectional view at this point, and I will just use the metric 12 for internal this hole. Make internal. This time we have 28 millimeter, 27. I'm sorry, 27 millimeters up to here, and I'm just going to make the all the way thread because I do not see any detail in the technical drawing at this point. Oh, let's change a little bit. Let's reserve 1 and 2 millimeters. Let's reserve 27 millimeters, which is shown here. Okay, and this is on the other side. I'll just change this time, 0 this point, and 27 from the other side. Change the way I can change. This is the way it just begins. I'll just select the surface again here to this point to make this one. Okay. The other sides are not very clear, but I think we have a chamfer starting from 13 millimeter to 7 millimeter at this point. Let's make also that chamfer here. I'm going to start a new sketch on XY plane, and I'll just create a new line for revolve. I can also use the axis for Y axis for revolution, but I'm not going to use that one. I will just fill the gap here, starting from 13 millimeters. Get the first this line. I will just get this line like this. Also, I will get this geometry to have a closed loop. First thing I need, it is 7 millimeter for this dimensioning purposes. I will change the center line property, this point to this line, which is 7. Also, I'm going to make 2 millimeters. I think we have a 1 millimeter reserve at this point for this. I will just delete this one, delete this dimension. I will just leave like this, give the dimension here, which is 2, and move this one, move this point, this line, back, downside, to have the dimension on the top side, which is 1 meter. I'm not sure about this one. We will just make this correct after we have finished things. I'm not going to make this one construction. Finish my sketch. Add the revolve tool. This time I will combine these two like this. We have a connection. We have a hole up to this point, and after that we have a chamfer point. Probably it will just sit on this surface. Okay, I save my part. It has a warning. As I have told you before, if we have this half section view, and we can save this half section view with the new button. I'll just make the section with and save my part file. This is my master view. This is my section view. Okay, this is the part that I have. I will continue. All the other rest of the parts are all mostly the revolve, the cylindrical parts. We have the number 3, the knot part, which is the cap knot. And for this, I start a new standard millimetric IPT. The first thing, I need a hexagonal shape. The dimensions are not very clear at this point. Let's just assume. Again, I think it is about from this I can just think this one around these two lines like this. These probably have the same diameter. Let's assume that one. I'll change upon the center point visibility and XY plane visibility. From this point, I'll just go up and create the first thing, our first part. I'll just use this portion. Okay, let's create the first thing. I need a sketch. I need the sketch on the front view. I use XY plane. I need a polygon, 6 sides. I use this point. I will just make one side horizontally constrained. And from this one, I will make this line tangent to, and I will define the packing knot here, dimension, which is the same we had used in our example, which is the same. It is 28. I will just make this part 28, and I will just correct it. Yes, I do not need this part, but I need the whole part, which is 7 millimeters. From this part, let's go up and just check our part again. Yes, we have 7 millimeters. Also, we have a metric thread on the other side, but I'm going to make that with the tool. We have a 15mm extrusion length. I will just finish my sketch. Have the extrusion tool. Make this one and extend this extrusion tool with 15. On the back side, I'll just create a new hole on this face. Make this point coincident on this hole. And this time we have a metric thread with a depth 10mm. Metric 18, which is this one, with 10mm also for thread, and also for the whole side, like this. We'll just create this side. This here. I'll just make the half-sectional view like this by using XY plane or YZ plane. Our view is probably XY plane, XZ plane. Have the view half section, which is this one. Let's check our view. We have the half section view. Okay, I'm going to save the part which is gland tightening nut, part number 3. Make enlarge, save. Before this one, I will just save my view. This is section. Okay, next thing, save the file, part 3. Gland tightening nut. I'll just close and open a new part file from this. We will just continue with the gland part, which is number 4, as seen here. This is also another cylindrical part. It's very easy to model it. I will just follow one side here, this outline, and we have only one center axis. Start a new sketch. I'll make to see a little bit. Have the center point visible, XY plane visible. Start a new sketch on XY plane. Align with escape. Convert this line to center line because we have diameter features here. I'll just follow this outline and draw. For this connection, I will just choose this point, the top point, as origin point, this one, and I will just start a new sketch, a new line, convert it. I will just combine this line to this line. Just continue to draw the outline like this. Go up like this. I will combine and make this line offset. Okay, let's define the dimensions, which is 7mm, the smallest one. Total height, this point, which is 10, and we would like to keep. I would like to keep this point or this line and the origin point I'll just stick to this point. You see, we have only one thing. I'm just going to make construction. I can just extend, stretch it. I'll just use 6 and this time 2 millimeter in height. Outside dimension, it is 6. I think it is 8. This one, it is 2 millimeters. And I will just define the outside dimensions, which is 16. We have a blank tag, which is 13. Okay, finish my sketch. Extrude tool. Make this partly this. We have a conical shape. On the top side, we have a flat surface. Save this. Number part 4. This file, open a new file. I'm going to make the 5th one. I think this is the 5th one. We have a sleeve part. Number 5, sleeve. It's again the same part, but we have a threaded fastener at this point. Open the center point, make this one visible. Start a new sketch. Online. I'll just make this move to see during modelings. I'll just erase the line. Convert this line to center line. I'll just follow from the bottom side. I draw an 8 line. Convert it to construction because I'm not going to use it. I will continue to make the outline which I have seen in this figure and make this point coincident on this line on this point and make the trim, give the dimensions which I have seen. The biggest dimension 20 here, the biggest height it is 10. This portion it is 3 millimeters. Also we have 7 millimeters from inside. We have 15 millimeters from the outside. Normally we do not use 15 millimeters during the modeling side. Let's check. Have the revolve tool, and after this one we have a threaded 5 millimeters from this point. I'll just make the isometric view visible, have the thread. I'll start near this point and make this thread not the 28. I will just make it 5 millimeters with the thread. With ANSI, I will change it isometric profile. Save this part, the 5.5 dash sleeve. Okay, the next part. It is the 6th part, the collar. I think it is on the bottom side, which is next to this part. Yes, as you see here. So again, this same kind of part. It's a cylindrical part. It's start a new sketch, new part, I'm sorry. At the center point visible, XY plane visible, start a new sketch on XY plane, again the line, then convert this line to center line, I get this point. We have to raise, we have the threaded fasteners at these 2 points, which is metric 15 and which is metric 4. You can use the whole command. One of them I'm going to use the whole command. For example, on the metric 15 side, I'm going to use that one. Also, for the metric 4 side, I will just make the whole feature. For this reason, I'm going to use this outline, or let's use this outline because we have the dimensions on the other side here. We have the dimensions. Let's create a full solid part like the profile, something like this. I will just continue from this point to this point. Next thing, I will just define the diameters, which is the biggest diameter. I'm starting with this, which is 30. The biggest height from the bottom side, which is 17. We have an 8mm portion here. We have a 7mm portion here. And we have 20mm diameter here. Just change this one. Finish my sketch. I will just make the whole feature this one, this time. I have a slope at this point, as you see here. It seems a little bit weird. Let's check my dimensions. 30, 20. Okay. Yeah. No, it seems no problem. 7, 8. It is also the same. Anyway, we will correct it. Save the part file. It's 6, which was color. Okay, the color. Okay. I'm going to make the whole commands start. The first, I will just make the 15mm. The depth here is 5mm and the total depth of the hole is 12mm, and this is also 8mm up to this point. I will just start a new hole, stick to the origin point and change this dimension to 15. It is a blind hole with 12mm, which is 17 minus 5mm, and the thread is 8mm. I'll just change this thread to 8 and this dimension with 12. Okay, just make. Okay, I think I have made a mistake. I cannot stick this point to origin. Finish my sketch. Okay, correct it. From the bottom side, I will do the metric 4 thread. Again, a hole. This time, this surface I use I can use the origin point directly, but it's better to select the surface. This time I'm going to change the dimension with 4, and I have a 5mm thread, at least 5, also 5mm hole. Let me check the half section view. See, and I'll just save this half section view. Rename section. Okay, same part file. Okay, this one. I'll just close. We are not going to make the part 7, which is the packing gland here, stuffing box packing. It's a phantom part here. We just call these parts phantom. It is in the part list, but we do not see in the drawing, or we do not have any drawing, something like the package for your product or other things. I'm going to make this number 8. This is a shaft size, and in this view, the shaft is collected together with the nut part. The bolt or screw part. We are not going to make the screw, actuating screw and this one. We will just use this end part from the content center, which is the material library of the inventor. Okay. What I'm going to do is I will just make this shaft part. It's a long part, one by one. I'm going to start with 7mm diameter, starting from this point to this point, which is 12mm, and I will just create a hole with metric 4, with having the depth 7mm and 2mm, totally 9mm in hole, and 7mm with the threaded length. I will just continue with starting. I'll just move this one, and I will just create a new sketch, new part. Start. In the figure, I will take this point as my part origin, and I will just add up one by one. I'm not going to make this part with the revolve section. I will just do the extrusions one by one. Create a new line. I will just start a new sketch. I have the dimension, which is 7. I'll just make the first extrusion, which is 12. I would like to keep this point as mounting point, which is 12mm. In order not to forget, I will just create a new hole at this point on the surface with the metric thread 4, as you see, with total 9mm. This time we have a conical end at this point, not the straight this time. We have 7mm thread with 9mm in length. With OK. The next part, I will just make a 12mm with 16mm length cylindrical part. I will add at the back side of this start new. It is 12 and make 16 millimeter in length to the other side. Also, the new thread, which is metric 12 whole length. After this, I'm just going to add a new portion, which is again 7 millimeters with 65 in length, probably. Just look for it. Yes, it will be 65. Okay, start a new sketch. I can also get the other side dimension, but I'm just going to use a new sketch. Dimension, it's this portion is also 7 millimeters. I just prefer to use another dimension. Have the extrude tool, 65. This is the part here. On the top side, here we have a different sizing or different representation, like the crossed shaft. This means that in the technical drawing, we show the square parts, the portions, in one section, in one view, like this. Also, we have an information about the size of it. We have a 6 millimeter square, which is added to the top of, or this side, this surface. We have, and I'm going to add a square portion here, which 9 millimeter in height, after on this surface. For this, I start a new sketch. This time, I'm going to use a center point rectangle and make this point rectangle, something like this. Since it's a square, then no need to change, but I will just make the two sides equal to each other, and I will just make one dimension, which is 6 at this point. Finish my sketch, add the extrude tool, 9 millimeter. This portion. Okay. And after this one, we have a shaft portion, a cylindric portion, with having the metric 4 thread, 7 millimeter, and reserve at the bottom side with 1 millimeter in unthreaded portion. Start a new sketch again. I will use this one. Arrange the dimension to 4. Finish my sketch. Have the extrusion tool with 7 millimeter. Add a threaded portion starting from this line end, and I will just make this portion to be threaded 6 millimeter. Again, I just select the surface very close to this portion, like this. I have just reserved 1 millimeter, which is shown here. These parts are our parts. I'll just save number 8 here, which is called stem with screw. Part number 8. Just rename it stem with screw. Okay. next thing, we have an actuator screw end, which we will just bring this part, this bolt or screw from the library content center. I will just make the next part number 10. I'll search for it. I think let's make the bigger side. Okay. This. It's a very simple part with 15 millimeters metric 12 threaded on the outside. We have a hole with 7 millimeters. For this, I'll just make a new part file. I'll just save and close a new part with part 10. Start a new part. This time I'm not going to make the for outside diameter. We have 12 millimeters metric thread major diameter. For this I will just use metric 12 and 7 millimeters for inside, and this ring is, I will just keep the symmetric whatever it is, which is 15 millimeter in length. I will also add a thread section with isometric through all thread, which is seen here. The 11th part, we have a valve seat, which is this one. Next to it, it's a normal washer side, not a complex part. We will just make this part with a normal simple extrusion. I'll just save this part first. This is the part 10, and the name is screwed sleeve. I'll just part 10 sleeve. Again, a new part. I'll just add a new part here. What I'm going to do is upon the part 11, we have a washer with 23 2 millimeter 4 millimeter inside diameter with 2 millimeter in thickness. I'll just create. It's a very simple part. Start a new sketch on XY plane. I'll just create two little circles, two circles. The biggest one is 22, small one it is 4. And I would like to keep the symmetric extrusion 2 millimeters. Okay. And this one, this is the part 11, which is valve seat. We have only one part left for part modeling. Valve seat. Close this one. Again, a new part, which is the hand wheel. It's also an easy part, which is this one. Last week we did a simple same part, similar part to it. That was also much more complex than this one. I have just started a new part. Let's move a little bit more. This time I'm going to select the midpoint center upon this. From the top side, we can just make a revolve section, start a new plane, a new line with horizontal constraint, take midpoint to this midpoint, convert it to center line. Here I will just make the full side here a rectangle, starting from this point, another rectangle. Let's make this part later. A new line for this center line. I'm just going to make a center line and connect this ring, this donut shape. Okay. I will again add a line. And I will just, I'm not going to use this one, change it to construction. Also, I will just make a symmetric condition around this line. We have 70 millimeters of this half part. Here we have 70 millimeters. With the height, it is the same height with 10 millimeters. Also, we have the ring at the end of this point here. This ring is 10 millimeters also, and this point has 65 millimeters. Far from this. Finish my sketch. Add the revolve tool, this portion around this one. I have the donut shape. Start a new sketch by using XZ plane for these arms. I start a new sketch like this with F7 tool. I will just go inside, create a new line for symmetric condition. Make this line symmetric. I will just make symmetric around these two lines. Okay. The thickness of this arm is 4 millimeters, and it is stick to inside of this figure here. Also, it is kept inside. This is enough for this part. Have the extrusion with 4 millimeter thickness. Again, first the distance extrusion length with 4. Change. Do not forget to change the symmetric condition here. I will just make a copy of these two arms around this. I need 3 copies like this. Also, I will just make the fillets, which are these 3 millimeters. This one. On the other side. This is also on this side. Also this one. We move this fillet and also copy this fillet properties to these, and have the copies with the fillet features. Also, I'm going to use the top side again to see better. Start a new sketch on XY plane, which I have the 6 millimeter square extrusion here. Again, I will use the thread rectangle and have the F7 tool. Start a new rectangle here. Select and make equal, because I'm going to use a square thread a square extrusion, which is this one. Make this one. Have the extrude tool. Select inside profile. Cut through all. It's symmetric. Save the hand wheel part, which is, I think, the last part, 13. 13 with hand wheel. This is the part files which we have so far. After this one, we are going to use the assembly modeling.